Let me now introduce our VIP, Kaisa Marton. She is the Managing Director of Kamelia Cleantech. Kaisa is a hands-on project manager and technical specialist with many years of international experience with Wärtsilä in 2007 at a power plant installation in Turkey. Since then, she has worked on varied projects in different capacities in Italy, Hungary, Turkey, and Timor-Leste. Is that the same as East Timor?
Yeah.
Oh yeah, Timor-Leste. I'm an engineer, don't know too much about geography. She has extensive experience in the exhaust gas cleaning industry, having been working with marine scrubbers since 2011. Kaisa, being a specialist in scrubber chemistry and process control, subsequently continued her career in scrubber design and development in Norway, working with the Kamelia team in more than 50 scrubber projects. After her work in the scrubber division, she was appointed project manager by Wärtsilä Executive Management to turn around the delivery of Kraken FPSO power modules in Batam. Subsequently, through diligence, organizational skills, technical versatility, and sheer hard work, she successfully executed the $70 million and 150 to 450 personnel project and achieved over 2 million man hours without LTI. Big achievement, huh, Dubai Dry Docks? Thereafter, she continued to work as a project manager for integration and commissioning of the power modules with the Suez Max tanker infrastructure and systems at Keppel shipyards in Singapore and the Netherlands. After this, she worked in Scotland to ensure a smooth handover to operations. She has since moved on to start her own exhaust gas cleaning turnkey solution company with 4 other founding partners, including senior oil field executives. Tervetuloa Dubai, Kaisa.
Thank you.
I hope you're impressed with my fluent Finnish. Our second speaker is Sharad Kumar, who is the Group Director for Business Development of the Unique Group. Sharad began his professional journey by serving as a marine engineer on board tankers and container vessels. He quickly progressed the career path and worked as an automation engineer, progressed to become an automation engineer. That means marine engineers are automation engineers here. Okay. Providing customer support for marine automation and dynamic positioning systems. Sharad has been part of the Unique Group since 2005 and has worked within many of its specialist teams during this time, including the customer support division which he initially set up. Management of feasibility study, systems analysis and design, AMCs, services, installation, commissioning, projects, systems integration and training on various marine and offshore automation systems, hydrographic survey equipment, ROVs, marine energy efficiency management systems, are some of the areas Sharad has been proudly associated with. Sharad has been associated with business development and management in the Middle East, North Africa and India through channel partners, branch office setup, joint venture formation and territorial expansion for Unique Group's marine, offshore and subsea systems. In his current role, Sharad is heading the group's business development team where he spearheads customer relations and is responsible for overseeing large-scale international projects. Alongside overseeing the growth of the company operations worldwide, he is also heading the India office operations and serves as the company's managing director. Sharad has recently been awarded a PhD degree for his research work on strategic management of marine energy efficiency optimization from the Banasthali University in India, in Rajasthan, India. Welcome, Dr. Kumar. I now hand over to you.
Thank you so much, Nikhil. That was very kind words. I was just wondering who you're talking about. Yeah. Thanks, Nikhil, for the great introduction to us, and also a very scary picture that you put it up onto the scrubbers. I know you did your homework, you made a detailed SWOT analysis. I think that has put more questions into the team over here. Alright, marine scrubbers. So what we are planning over here for the day is to have more towards a general awareness of the scrubbers and various solutions and all attached along with that. Believe me, it's more kind of a technical discussion, so what we are intend to do. Just share our knowledge and our experience, what we have gone through, and then it may be of help to the when we do the feasibility analysis for you, and also for the technical team within the company who more focusing on these scrubber projects. Before we get into the real technical talks, let me just have a chat about Unique Group. Unique Group is known for almost everyone of you as a marine and subsea, but we are not just on the marine and subsea. It's quite a diversified company, present globally, and the company started off almost 25 years back on the survey equipment. When I say the survey equipment, we are talking about hydrographic survey, mostly for the bathymetric, geotechnical, all kind of subsea survey. The company started as an equipment rental, and then slowly throughout the years it has grown into multiple verticals, as you can see. And even now, the survey equipment or the survey division is one of the key pillars of the company. Second one is the diving. I think we are one among the top 3 saturation diving equipment manufacturers in the world. That keeps us quite occupied with complete solutions for the commercial diving. Can be side diving or air diving systems and everything. Buoyancy, definitely we are the market leaders now on the buoyancy systems. We manufacture the airlift bags and the waterload bags in Isle of Wight in UK, and then we got the kits all around the world available on sales and also for the rentals for various projects. On-site engineering is one of the services division within the Unique Group, which takes care of pipeline intervention services. So there, in that division, we really work on high spec required kind of a pipeline jobs. We got into hot tapping, leak sealing, subsea services. Specialized boats, we are specialized, that's coming as part of the diving, where we manufacture in Holland hyperbaric lifeboats and also special daughter crafts and all. Medical technology, we have pioneered into medical technology recently, where we are manufacturing and also operating hyperbaric oxygen therapy systems. Anyway, come back to marine and subsea. We've been associated with automation systems and integrated packages for almost 20 years plus in this region. The solutions that we've been bringing around, that are always associated with pioneering solutions, whether it was our long relationship with Kongsberg or when we introduced the energy efficiency systems on the naval car, it has been already some difference what is packaged by us. Definitely that you can expect from the Kamelia as well. Just a brief few lines about Unique Group. What we believe is in the customer support. It's not just about offering something, but being with the customer throughout, right from the design or feasibility of a project, and work throughout till we commission it, train it, and then the life cycle goes on with after sales support. Over 600 people worldwide, out of which most of them are engineers. Even over here we have a massive customer support which is replicated on all our locations. That's pretty much how we cover the global scenario for marine. You can see wherever the major marine hubs are, we are present. It's not just offices, it's where our spare part support, our service support is available. Coming to the fabrication facilities, apart from UAE, we also have the similar kind of capabilities in different parts. So as per the vessel's requirement or the vessel's training pattern, we are there, support you and also fabricate the solution for you. Alright, this evening, I know we gave just a snapshot of what we go through. I thought I'll just go in a little bit in detail about what you can expect from us. A lot of legislative talks are going around. When we just start talking about scrubbers, we were all familiar with these IG systems on the tankers as well. So everybody was thinking, okay, yeah, I've seen the IG. Even when I was thinking about the scrubbers, I thought, you just spray the seawater into the exhaust gas and then whatever sulfur magically just goes out into the sea. That's it. But once we started getting more into the challenges inside, which definitely we want to discuss further. It's not just that. A lot of design, a lot of chemistry has gone into it. We'll go through a little bit into OPEX and CAPEX and the opportunity cost, followed by everybody looking at it. I know I'm talking about the question and answer session. All right. Okay, that's it. And along with us we have Richard here. Richard, please. He's the chairman of Kamelia Cleantech. So he's also joining us, and he will be available for if you have any further. He got years of experience in oil and gas, FPSOs and project management. So let's get into it. Oh, that looks like something from the chemistry textbook. So Kaisa, can you just get us through that?
Yes, I hope you can all hear me because I haven't tested my mic out before. So here it goes. So these are the limits basically required in the legislation for 2020. And I'm sure most of you, if not all of you, are familiar with this, so I'm not going to run through them in much detail. What is interesting now is that ports can set their own discharge limits. So it's not just the global legislation, it's the local legislation that is of interest. So now Fujairah and Singapore have banned the use of open loop scrubbers in their areas. And many EU ports have done the same or are following suit. So many of the ports and areas are undecided on what to do with the scrubbers in the future. So that creates some kind of a distress for ship owners because they don't know exactly what to do.
Are we allowed to interrupt you during when you're speaking,
Yes.
or shall we wait till the end?
You're allowed if it's important, yes.
When you brought up the regulation which has changed for open loop scrubbers,
Yes.
are we talking still on the main engine and other things? Or does that now include the scrubbers that we used to use on tankers for inert gas?
That is only for the sulfur emissions. So that is for the outlet of sulfuric acid, so to speak, to the sea. So discharge of sulfur.
So they're not banning the IG scrubbers that we used to use on tankers. Those are still allowed.
Yeah, it's mainly on the discharge to the sea. That's what they focus.
Still
But
discharge
there is a lot of issues on the clarifications on where the limit starts and how it is. Even we were just discussing about the ports in the UAE. So it was a statement made, and I think the clarifications are coming out one by one. Yeah. The main thing is it coming under my port limits, or where does it start? So how does it? That was the discussion.
I hope I was clear enough.
Yeah.
So
By the
IG
way,
scrubbers,
my
yeah.
name is Arvind
Yeah.
Ahuja. Let me introduce myself.
Yes.
My name is Arvind Ahuja. I'm going to ask you this specifically again.
So
You
IG is
have- you
inert
have-
gas scrubbers, yes.
You have brought in, or you have made a drastic change in the marine environment
Yes.
by introducing scrubbers. Now the legislations are looking at scrubbers and they're saying, okay, no open loop. But unfortunately, open loop has been used on, sorry, I think everybody was able to hear me before. Or should I repeat that?
No.
Okay.
Please don't repeat.
I love your talent. Okay. So going forward, does this affect our existing scrubbers, which we were using for inert gas, and also does it affect the IGGs, the inert gas generators, because they are also all open loop? So now, does this legislation now, do we have to start looking back at every other system that we use? You have opened the Pandora's box.
Yeah.
How does that affect us?
That's one of the clarification which we already sought with the port authorities, and also because the notification that we were going through from the Singapore port. So what they have clearly mentioned is that open loop scrubbers for the main engine exhaust gas systems are not allowed within our port limits. So on that, they are not going to the second level about IGG or anything.
Okay, fair.
So they were very clear on which one is coming under that. But then the question was raised, one of the sessions with Singapore was that, if you just cross few kilometers, you go to the next country next door. So what happened? Can I just go there and do it? And then if I'm coming to Fujairah, can I use it within the port limits? I just go few on the Alpha anchorage, can I go to Kofakan? Is it okay? Those things. So a lot of clarifications are going on. Definitely they're going to come back. Same thing is with Hong Kong. So they don't have an exact clear picture on where the legislation starts, where it ends, and what is the specification. Hopefully it will be clear soon.
So if you look at many of the EU member states, basically what is their thoughts on this subject? they just say that we don't know yet, so we are investigating. So it's the same for many other states. They are investigating. They don't understand this technology yet. So let's see what happens.
And I think for everybody, I'll just remind you, make sure that you by heart all these numbers. She's going to raise some questions after this session. So there's a quiz competition over here.
Yeah.
All right, so Kaisa, I mean, everybody is talking about solutions for it. Scrubber is, I'm sure everybody knows, scrubber is not just a solution. There are various options. IMO has come out with a very strict regulation saying that 2020, Jan, that's it, no more emissions. So how we want to do it, why we want to do it, that's up to you to decide. So there were a lot of questions going around the similarity of this implementation along with the ballast water treatment. Everybody was saying, yeah, we know ballast water, we've been talking for long ages, it's going to change. But then when we were talking with representatives, what they're saying is that, but you do have a lot of options to comply with the emissions. So some are over here, maybe you can go through it one by one. What options are there? Here we are not just talking about scrubbers, what solutions are there?
Yes. So as you can see, there are several options to comply with the new regulations. And for different vessel owners, it's a different solution. So we don't say that scrubbers fit everyone. So for example, for smaller vessels, it is easier to switch to using compliant fuel because of the high capex associated with scrubbers. The difference between the two fuel prices for last year, it was $252 per ton for 20 port average. And that is the driving force basically behind selecting scrubbers versus MDO or MGO, low sulfur fuel. And it is easy it's the easiest solution. And what you can do is you can switch to MDO in 2020 and you can still decide if you want to have a scrubber or not. So I guess many people will be hedging their bets and seeing what is going to be the spread in 2020 and so on. Another option is blended fuels. For example, now BP delivered a huge batch of blended fuels to Singapore of 0.5. There is no demand. So at this moment, so the price was very favorable. But what happens, in fact, is that you're mixing high sulfur fuel with MDO or MGO, and you're in fact putting 6 parts in of the more expensive fuel, and you're putting 1 part in of the cheaper fuel. So the price will be somewhere in between. It depends on, of course, how low sulfur HFO you can find. LNG, very expensive conversion. Okay for some ships, but most ships you will need to modify the main engine, cylinder heads, fuel injection systems and such, and you will need to have expensive LNG tanks, regas and gas compression again. So it's big, large equipment that you need to fit in, not in the funnel, but in a different position. So again, it's attractive for few vessels, but not for all. For methanol, the calorific value is less than for normal fuel. So you need to burn twice the amount of methanol to get the same efficiency out, or the same output out of the engine. So you will need to increase the capacity of the tanks on board. And in addition to that, you will need to have pilot fuel diesel. So you will need to change the engines to have 2 fuels. So this means new cylinder heads, new fuel injection, and a lot of cost, typically 30% of the new engine cost. And biofuels, attractive in some regions because of the subsidies, but that's the subsidies game. You never know what is going to happen with subsidies. One of the things with biofuels is that it contains a larger amount of water than regular fuels, and you will have some corrosion issues with the engine as a result, and more frequent overhaul periods. And then batteries, again, Sharad?
Yeah, batteries have been discussed for a long time now. And, people have been talking about the electro or hybrid systems, and then either directly into the propulsion, or you have a reserve battery pack, maybe in 10 feet or 20 feet containers sitting there, tapping into the waste energy, store it, and then use it back whenever you need. So that's also in pipeline, especially I've seen on the electric propulsions and some smaller fisheries vessels and also on the autonomous vessels, that's what they are all looking at it. But it's an option, it's an availability, it all depends on what size, how much discharge, it's all limited by the battery's capacity. But that's also being discussed as a solution. Then definitely scrubbers, and you mentioned for larger fuel consuming vessels, is that so?
Yes, well, it depends on the fuel difference. Again, please do continue. Yeah, please.
You said batteries. Is that for propulsion or for the lighting effort? Because I don't think the batteries yet have that kind of capacity.
It is for propulsion we are talking about, and we do have some experts in this region. If you want to have a chat later, definitely, yeah. So we can look at that. We are doing some projects on that. It'd be good to discuss further.
Thanks.
On that.
I've just been told, let's keep the Q&A till the
Yeah.
end, so we'll keep
Okay.
it.
So, next slide.
Like any questions?
No.
All right, go ahead. Yeah, there you go.
So, this is very typical chemistry. You will have seen this before if you have ever looked into scrubbers. So, what happens inside the engine? You're getting SO2 or SO3, 95 to 5%, and then the reaction chemistry with water is that you get sulfuric or sulfurous acid. And the pH of the scrubbing water out of the scrubber, that's the baddie that we are talking about. That's why we are banning open loop use in certain areas. It is equivalent to the pH of orange juice. So it is no more dangerous to the environment than orange juice in high alkalinity areas. So if you have a freshwater area, yes, we understand. The other thing is that it is very dangerous to carbon steel. So anything low pH, you don't want to put it in contact with carbon steel. So that is something we need to look at. But environment-wise, in open sea, no real danger. There is sulfur anyhow in sea.
So you mean to say that the outlet from the scrubber system
Yes.
is almost same as the orange juice?
Yes.
That's what you think?
Yes.
All right, impressive. I didn't know that we are not supposed to put orange into the sea. I didn't know that. Anyway, that's coming into some environmental aspects. It's good to review the environmental aspects from the point of view of the scrubbers.
So this is just a simple illustration. What happens if you put SO2 in the air? It does travel far. So it will rain down as acid rain, and it will have detrimental effect to trees, to wildlife, and it will rain. The rain will eventually gather in rivers or lakes, which will eventually lead back to the sea. So here, with scrubbers, we are taking the atmosphere out of the equation. In simple terms, of course, there is going to be some deposition on Earth and such, and but sulfur on its own is not dangerous to seas, but there are some exception areas. We go to the exceptions next.
Yes.
So, yeah.
Go ahead. It's a colorful picture.
So that's a nice colorful picture. Seawater has excellent capacity to buffer the changes in pH, but not all seas are seawater. So here we are looking at Baltic Sea, which has very low alkalinity, close to fresh water. So if you actually deposit sulfuric acid or scrubber residue there is not going to be such a good buffering effect. So we do understand why you wouldn't necessarily operate in open loop in all of Baltic Sea, but as you can see, the areas are very few and limited where the operation restriction actually applies. So it's closer to Russia and closer to Sweden and Finland at north. And alkalinity here doesn't mean the pH of the water, it means the buffering capacity. So it means what happens, the flow from the rivers surrounding the sea area. So if you have calcium bedrock, you are going to have high alkalinity. And if you have granite, you're going to have low alkalinity. So that's basically it. So these are typical seawater alkalinities. Most of the open sea is more than enough to compensate for the scrubber effect. And then next one. And salinity is a good indication of alkalinity. If you have a sea where you know the salinity is high, alkalinity is typically also high.
From the design perspective, what do you think that the seawater alkalinity, salinity is? Do you really consider those things when you are into the design?
Well, we need to, because that leads to corrosion issues as well in high temperatures. So you need to select the materials as per the worst case as well.
Okay, then let's get into the scrubbers, which is the main topic of the day. Let's look at what are the options available into that. All right, so traditional and inline types. I think it's a pretty standard solutions available. It's more kind of a comparison between these two. Instead of going into the how it works or anything, everybody has been discussing on just to compare it.
So there are two main types of scrubbers at the moment. Doesn't mean that there are not going to be more scrubbers in the future, and hopefully there will be. But the two main types now, they are one is the U-line, which is the traditional scrubber, and one is the I-line inline scrubber. So U-line is the likes of Alfa Laval are doing that, and I-line is like Yara type of scrubber. And for both, they have their benefits, pros and cons. So U-line, it's more energy efficient because you have more contact with the exhaust gas and water, because you have packing inside the scrubber and you have venturi inlets. And it works in all sea areas because of this efficient contact. And it can be bypassed with bypass dampers. And there is no risk to the engine because of this bypass possibility. And the water cannot quite easily travel back to the engine even if there is a malfunction in the scrubber. And maintenance-wise, it's easy due to the bypass aspect again. And it's wider than the inline scrubber, so it will require more space in the funnel. That's a definite con. And it is higher in capex because of more expensive components, and it's being larger and you're using more material. And inline scrubber, it's narrow and tall, so it's a very small footprint. It's very easy to install on retrofits. And it can be run hot, so you don't need to bypass it. And it has a lower capex for the scrubber itself because it uses less material, and also installation capex is lower. And you have higher water pH out of the scrubber because you're using more water. And so the corrosion issues are slightly mitigated there. And it has much higher energy consumption and OPEX because you're using more water again. And maintenance issues if you have a single main engine because you need to run it hot if it's out of operation. So how do you access it when you need to run it hot? You need to cool down the whole system to actually maintain it.
All right, so let's get into the open loop. We just looked at the various scrubber options, and let's go into actually how it comes into the vessel system, how the entire system, the circulation and all goes.
So the open loop, it's cheaper in capex and opex because you're not using any chemicals, so you don't need to spend any additional money on chemicals. And it works in most sea areas, so key being sea area, so it works at sea. And it's easy to operate and to maintain, so you don't need that much specialist training because there is just basically water in and water out, as you can see from the diagram. And some seawater pumps which ship owners are used to, and nozzles. And it can be used in conjunction with plug and play kind of fuel switchover systems, which means that you can actually switch over faster than the normally required 1 hour from HFO to MDO when you go into ports with zero discharge requirement. And it has large energy consumption because of the very large seawater pumps. We cannot get over that with open loop, unfortunately. And it cannot operate in zero discharge areas, as mentioned before.
Yeah, that's one of the key points on the open loop. As you see, it's a very simple system. We just have a circulation gas, like our seawater circulation systems. It's almost similar. Only thing it is got a separate inlet, separate outlet. But this is the key point on that. The ship owners who is opting for an open loop, suppose if they're operating in difficult areas or non-discharge areas, what they prefer is to have a quick changeover system. So let's change over to diesel oil, let's approach the port, and then once they're out of it, let's again move back to open loop. So that's one of the options which has been going around. But then the similar one can be adapted into a hybrid ready like this.
Yeah. And one thing about open loop, also there is restrictions in US coast as well because of the high pH requirement out of the scrubber system. But with hybrid ready, it's the same as open loop, This is a typical solution provided by many scrubber providers, this layout. What happens there is that you can make it hybrid ready. You can just remove all of the stuff after the red circles from the system, and it's again open loop. So it happens the other way around. You can do that as well. So these are removable spools, and then you can remove them and put in the closed loop equipment later on. So it can be quite easily converted into closed loop later if that is required. It does require installation work and such, but that's something we are more than happy to answer questions on. It has also the same high seawater pumping capacity, so it is not completely optimized. But it has energy saving modes. So.
Yeah, so that's the thing. Then we come to the next one, the hybrid one with a one-stop solution for everything, I think.
Yeah, this is also a typical, just a process diagram for a typical system, and it works in all seawater areas. That's the pro, and it can work also in freshwater areas if you're going up Mississippi, for example, and then going back to the sea. There is no fuel switchover required, and the issue is, of course, that it's higher in capex and opex because you're using. You have more equipment to install, that's the capex, and you're using alkali, which is very expensive, that's the opex. And it does require complex control systems, up to 7 control loops, compared to open loop, which is quite simple.
Can you explain more on the complexity of the controls? Definitely you can see a lot of components here as a ShipEM. I mean, we prefer to have a very straightforward system, and
yeah.
The less number of parts, less headache for us.
Exactly. So it's more headache for some, but it is easier in a sense. You only have to bunker one fuel. But you have pH control, density control, you have temperature control, you have, well, not in this system, but previous system, you have level controls, you have different controls for the scrubbing water power or how much scrubbing water you use based on the scrubbing efficiency and such. So it is quite complex.
So definitely can make what it looks like a system by itself.
Yeah.
All right. So we're going through the.
Sorry, just one. In this system also there is a overboard discharge, right?
Yes, but we it is held in a holding tank, so you can discharge it at open sea. So yeah.
I think it's more visible on here. There's a process tank, then there's a holding tank, and which is good coming to the discharge line.
So that you can hold in as long as required. So the holding tank is dimensioned according to your requirements and route.
So once you decided on the type of on the scrubbers, which type you want to go for, what as per your trading patterns, you do the feasibility analysis, everything. And these are the normal steps of any ship owner will have to take it once you get serious about the installations.
Yeah. So basically, now you have selected your scrubber. You kind of have a vague idea who you are going with, or you know exactly who you're going with. Then you contract the shipyard for the installation work, and then contract an engineering company if the shipyard cannot do the engineering work for you, and to do the integration engineering, the pipe work, the electrical routings and such. And then you need to have a naval architect to check everything and to coordinate everything for you. And all of these interfaces, these are 4 interfaces: scrubber, shipyard, engineering company, and naval architect. It's all coordinated by the client. So this is quite difficult for the client as it's a new challenge. How do you ensure that you will have a working solution? So this is something that we are looking into in more detail.
Yes, as you can see, there are a lot of partners involved in the entire process, which makes it definitely a difficult situation. So this is kind of an integrated approach towards the entire project. The steps are almost similar, which is what is required has to be done. These steps are definitely as part of the process. Maybe you will be doing it in a different levels, or different parties will be doing that. But it all starts with the concepts, and once it is the feasibility it's done, and you decide on that, definitely you need to go to the next step on the 3D survey.
So these are the basic steps that need to be taken when you're installing a scrubber system. And if you have more parties to manage this, then it might be more difficult to handle if you don't have a big project team as a ship owner in your facilities already. So
I don't know whether you can read over there. Just explain that it's a concept. Once the 3D surveying is done, then we have the exact interiors. Then we can go into the design, which is much useful when you're talking about on-voyage installations and all that, which you really prepare you. Then we do engineering, then the procurement, and the fabrication starts, the installations, all the pipe works, then you do the pre-commissioning, commissioning, and the harbor test and the final trials, and then you get the white smoke out there. I hope it's so that simple. Right? All right, project planning, and these are the critical design factors. Definitely, when as I mentioned, yes.
What is the capacity of the pumps that we are looking at, and the holding tank capacity is in relation to that?
The holding tank capacity is not in relation to the capacity of the pumps because in closed loop you're circulating the same water. Holding tank capacity is in relation to engine load. So how much sulfur you're actually putting to the system. So the bleed off is taken based on density. Density in the scrubbing water loop. So you are only taking out what you need to take out. And that is fuel sulfur content and the engine load. That determines that.
I hope that answers. Alright, so we had our approach, and then now we are in planning it. So the design, the critical factors which should be considered by everybody when you're doing it.
So basically, what we look at first is the engine sizes and how much fuel you consume. And we see, is it really necessary for you to install a scrubber or not? Is it profitable? In many cases not. But in most, if it's a large vessel, then definitely it is if you plan to have the vessel operational for years to come. This is the first step. And then we look at the funnel dimensions and existing space on vessel, if we can actually fit the system in, or if we need to make modifications to the superstructure of the vessel. And then based on that, you can see what is the approximate cost, and again, you can see the feasibility. And then we look at the ship systems, what is available on board. Do you have steam? What is required for the droplet separator washing? Do you have enough instrument air? Do you have enough power to run the scrubbing water pumps, or do you need to take up another generator to do that and such? And then we look at the ship geometry, where to place everything and how it affects the ship structure. And then we look at, of course, before that we look at class and flag. So class, everything needs to be class approved, of course, otherwise you cannot guarantee you have a working system and you have a safe system. And someone needs to verify that everything is working as per the design and it is compliant. And then we look at the ship operation pattern and schedule. So this is to determine if you need closed loop or hybrid or open loop, and what is the best option for you and what kind of OPEX you would have along your route. And then we look at dry docking schedule for your ship. So if your ship is going to be dry docked within the next year or so, let's of course do all of the work in dry dock. But if it's not, then it might be feasible to do at least part of the work on voyage. And then we look at, of course, in conjunction with opportunity losses, so how much it costs to take the vessel out of operation for that period, and if there is possibilities to do work on voyage. So if you have bed space, life raft capacity, and if you have sufficient lifting arrangements along the ship route to actually lift everything in.
Can you just brief more on the work on voyage? Is it really a saving for the ship owners to go into this kind of concept, and where do they fit in?
It depends on the operation, opportunity losses. So if the ship is out of operation and you're losing, let's just say, so 40,000 per day, yes, it's worth it. If it's a small ship and you're not losing that much money, then it might be worth going to a dry dock or alongside in a shipyard to finish the work fast.
So work on voyage option is there, so you just need to do the feasibility when you do that, just to consider that. All right, challenges definitely once, I would say that the most easiest part on the scrubbers will be up to the installation and commissioning, and then definitely it will start. During our sailing time, we all know that new regulation comes in, new system comes in, and the number of people on board goes less. We were running, I don't know how many, 6 people in the engine room for the tankers. So definitely we are adding more systems into it. A lot of challenges going to come in. So it will be good if we can share more on various challenges you face during your installation period, or it's during the design time.
Well, there are many challenges that can be that can occur when you install a scrubber system, and it is mostly due to either poor engineering or commissioning or operation of the system. So what you need to look at is you select a good water treatment system that actually treats the water, that it's according to regulations if you have closed loop. And one of typical other problem is overfeed of alkali. Alkali is very expensive. If you overfeed it, you're actually burning money. So you need to have smart controls for this, and you need to make sure that they work during commissioning, otherwise you are going to lose money. Other issue is vibration. There has been vibration issues with scrubbers previously, but again it has to be looked at with a structural engineer and with process engineers in conjunction to see that there is no such forces. And then one thing with commissioning is, or in operation, is collapsed or exploded GRE pipes. This is again inexperienced crew ramping up the VFDs too fast, or you don't have enough wall thickness on the pipes, or you're not taking care of the banging of the seawater to the pipes somehow by engineering solutions. So class approval has been also difficult in the beginning, but now class is getting more on board, so don't see really issues with that unless your system is not compliant. Other thing is turbidity. In some ports, the turbidity is actually higher than the required limit in. So you need to monitor both in and out. Fouling, if you're operating in closed loop and you're adding the wrong chemicals, you will have fouling of the pipes, fouling in the pipes, and or you can have some items growing in the pipes if you're not taking care of your filtration and the system properly. Acid rain, that was a typical beginner problem that doesn't occur anymore. Mechanical handling, what happens most of the time, you look at if the system fits, okay, everything is done perfectly, but can you actually take everything out that you need to take out? Can you operate it as per requirement? And software functionality, that is very, that can be challenging with chemical controls and these for closed loop. Most mechanical engineers are not aware of chemistry enough to actually design a system.
Very true.
Yeah. And well, basically, if you want to make an intelligent scrubber system, you have to encompass these things. So you need to understand seawater chemistry in general, sloshing, engine loads, and you need to have adaptive control loops.
You did mention about the corrosion. Are we talking about more internal or on the external hull?
Yes. Well, what has happened before on a couple of vessels is that they forgot to paint the external hull behind the scrubber outlet, and 7 meters or so from the scrubber outlet, you have had pitting to the hull, and that's because of the pH. It's very bad for carbon steel, as we said. So you need to paint properly and use proper materials. And no coated carbon steel for scrubbers, please.
Right. And we talk about some dollars. Definitely CapEx is one of the points, and I know different models are being introduced now. How to fund this? Can it be self-funded, or can it be funded by the banks or financial team? How to do that? Here we are talking about not the small amount which is coming into the ship industry, and we're looking at a bigger fleet. How do we do that? I think this will give us an kind of an estimation on what kind of figures we can expect.
So again, depends on the size of the scrubber. The smaller, the cheaper, and the model inline is cheaper than U-line, but again, OPEX is higher for inline. So, and the cost is between 1 and 5 million for the systems, and hybrid is the more expensive one in this. And of course, if you go to mega container ship or so, you will be at the high end. And you need to always use appropriate metallurgy because otherwise the lifetime of the scrubber can be from 1 month onwards. So it's not really attractive to use coated carbon steel. Everything needs to be proper when you install it. You want to install it only once. And basically the installation cost, it depends on where you're installing it. But the typical rule of thumb before it was that it was around the same as the scrubber system cost. Now it can be cheaper with China and such. And for larger vessels, it's around 2/3. And make sure that it's done properly and once only.
Definitely. That's a very strong statement. Right? I think when the class is involved, definitely, yes. It's not just CapEx. I'm sure you need to keep running the system. So you should be looking at the OPEX when you're doing the holistic approach. You should look at CapEx and OPEX and then take a call.
So the operating cost per year is anywhere between 150k to 600k, depending on the vessel size and how much fuel you burn and how large engine load you are using. And for the inline, it's approximately 20% more because of the larger water volume being scrubbed or used for scrubbing. And the maintenance cost is in the range of 40,000 to 80,000 per year, and that depends on the scrubber pump sizes. So pumps are expensive to maintain, but this is only occurring after the warranty period. And the ship, if it's a very large and it operates, 200 nautical miles from the U.S. coast, and in zero discharge areas, the cost can be unfortunately around $1 million for alkali. But typically the cost is much lower if you look at smaller vessels. So typical cost for port operation is around 25k per year. But if you go to a mega container ship, you're going to very high numbers. And sludge handling, it's cheaper than people think. In my opinion, it is around 5k per year. But it can be, again, for these massive ships, as high as 60k, but there are mitigating factors. You can look at alternative water treatment solutions such as filters compared to separators. And back pressure to the engine, it can also increase the fuel consumption. But of course, you need to mitigate that by designing the system such a way that there is no back pressure issues. Yes, the OPEX is higher than people expect, but that needs to be taken into account in the design process. And you need to select the best system for yourself so that you optimize on the OPEX.
We are talking about big numbers here, right?
Yes.
The CapEx and the
Yes.
OPEX. So, all right, there's another cost also, which is we should really consider it. There's opportunity cost on the vessel when you're doing it.
So this is the opportunity cost, which is typically 10k to 50k per day. And we're not talking about cruise vessels. If we talk about cruise vessels, we go higher than this, of course. Dry dock availability, time slots, they are in many cases at premium. I don't know, Majid, how is it now at dry docks?
Depends.
Yeah. Good. So there might be some room still at dry docks if you want to. And diversions, if the vessel is not near a dry dock where you install, the diversion cost, so taking the ship out of its route can be as high as this because of the lost opportunity cost. And that's why we have people like John Aitken there who do the work on voyage mostly.
Excuse
Yeah.
me. What about, you will be adding additional steels, right? For the weight will be additional weight.
Yes.
Added. So what about how we will compensate for, you are not calculated for the compensating the cargo capacity. Of course, it reduces the cargo capacity.
That's in the additional fuel consumed and the cargo capacity. We try to address that, especially with container vessels. because the containers are behind and in front of, in most cases behind and in front of the scrubber structure, we are trying to select the best solution that fits into the allocated space. And in many cases, it is possible if you design the scrubber bespoke for this particular space. For tankers, there is room behind the funnel, so you don't need to worry about lost cargo capacity, and for many other vessels. The biggest issue is for container vessels and such, where you have constraints and you have a valuable cargo space in front of the back.
No, sorry. It's the volume base, I agree. It depends
Talking
on
about the weight, the tonnage.
Yeah.
Oh, okay, all right.
The tonnage will reduce, right?
The tonnage will be there. It will be quite light systems if you use proper metallurgy. So the scrubber wall thickness will be from 5 mm to 8 mm.
So that will reduce the quality, right? If the long means it depends.
No, it doesn't reduce the quality if you use very high cost alloys.
I think that's why she was mentioning about the metallurgy, where thinner.
Of course, then the overhead costs.
Yeah, it increases the capex, but that's already taken into account in the capex calculation.
But as an owner side, we have to see the economical feasibility, right? So
Yes,
we
correct,
have-
correct.
That's very correct. That's, when you do the analysis on that part, you need to look at
Yes.
on the weight and everything.
That is calculated already into the additional fuel
Okay.
consumed.
Other thing on float, you were mentioning that on float we can do this, right? So once this large mass is fixed, so there will be stability issues and all those things. So how, I didn't understand on float how you can do this.
On float, how you can do this is you need to plan this and you do the lifting at quayside. So you make sure that
this has to take out of operation, correct?
So for this lifting, it can be between 3 and 4 days. That is more. That's less than the 3 weeks required in dry dock. So that is optimizing. So that you need to lift the equipment in next to a quayside anyhow, and you need to have proper crane capacity to do that. So that is a couple of days out of operation, but it's less than what would be required if you do the full installation at
No,
shipyard.
of course, the whole, this is not 1 kg or 2 kg, it's a
Yes.
big mass.
It is.
So of course the stability factor has to be taken into.
It is.
Yeah, that comes on the right from the design stage. It has to be calculated.
And that is done by the installation design of the process. So when you start the installation design, you need to see how the lifting plan and how you're going to lift everything in, and what kind of stability you need to put into the system when you're
Cost
lifting.
mentioned is only for the scrubber, right?
Yes.
The installation is additional.
We have we have mentioned kind of a split on that. If you look at it, the capex, the equipment cost is there, and then the installation cost is there. So and what you correctly mentioned is that weight is one of the concerns for everybody. We are putting a heavy equipment up in the funnel, right? So definitely the center of gravity, everything, the stability, everything needs to be considered. That goes into one of the very stringent requirements on the design stage. Definitely it's there.
That's in the installation design phase, and that's why the installation cost is so high, because you need to do proper engineering.
Yes.
And you need to check everything is stable.
Looks like everybody says like this then, right?
So why do we want to have scrubbers then? I have given you all of this bad news about scrubbers and all these bad figures and this, but still it's the cheapest solution for larger vessels. And the payback period is still between 6 to 18 months typically. So that is a strong winning case, even though the cost is quite high, but even with considering everything, OPEX, CAPEX, opportunity cost, the payback period is still short. The 20 port average fuel differential for whole of last year was $252 per ton. And major financial institutes are predicting that the differentials will be between $300 to $400 per ton in 2020. HFO is a byproduct of a refining process. Where will HFO go? It will still be available. You might invest more in refineries and you will have more MDO, but there will still be HFO. So what might happen is that MDO price might not rise, but HFO price might get lower. And then that means that scrubbers are still profitable.
Just explain more on this payback, because 6 to 18 months is quite an attractive payback period.
So 6 months is, in the case of a container ship, you're burning, the fuel difference is around 9 million per year. So that's simply it. And for a tanker, it can be less, or it will be less, and that means the 18 months. So VLCC is more like 12, 14 months. So it depends on the size of the vessel and how much fuel you consume.
Alright, that's good. So we just decided in favor of scrubbers then, right?
Well,
So then,
not for everything. So what we aim to be is basically a single-stop solution for you guys. So we are looking at this holistically. We are used to EPC project turnkey. We are used to installation. We are used to large projects with the oil and gas industry. So for us, this is not such a big deal anymore. It's a big deal for someone who has never encountered this before. And that's where we try to help. We need to, of course, design the system intelligently, as low OPEX and CAPEX as possible for the ship owner and the shipping case. And we understand the scrubbing process. Myself, I have masters in chemical engineering. I have studied scrubber chemistry quite a lot, and that helps in translating basically into a lower OPEX, into controlling the process. And we have marine engineers, we have engine experts who are able to help with other aspects and to look at those in more detail. And as you can see, marine engineer there as well, and oil and gas expert there. So we have a more varied engineering team who can look at all of the aspects. And we understand oil and gas standards, methods for planning and installation, logistics required for work on voyage. We can do hull penetration without cofferdams or dry docking. That's based on offshore technology, because you can never take a platform back, or you don't often take a platform back from the sea and do a hot or do a penetration at a shipyard. You need to do it at the location. And we have global customer support from the key marine hubs with Unique Group now. And we can have remote monitoring support and troubleshooting support.
Yes, that's I think pretty much about general in scrubbers. And then we just gone through the design aspects and how do you select, CAPEX, OPEX all involved, what are the issues, what you can expect from it, and how to go through that process, right from designing it or deciding what to do or whether to go for it or not, and then take it up to the installation commissioning, and then what Kamelia is bringing to the table as their one holistic approach. So Nikhil, I think that's all done from our side. You want anything else on the design
You have both the
sessions?
dry and wet system, right? You have both the dry and wet system.
We have only the wet system. We have a wet system in open loop and in closed loop. Dry system is not something we are familiar with at this moment, but we are looking into a dry solution with lower CAPEX and OPEX, but not offering it at the moment.
Yes.
Can you please show the slide where 4 agencies are involved to get the project going?
Oh, yes.
Yes.
This we've been talking about the process involved in the system. So when we go ahead, when you decide with the shipyard, and then you contract it, then there is a lot of engineering involved. There's a lot of amendments required on the as-builts and all that. And then the naval acts you need to come in, and then you need to coordinate all these things. So either you go for a single source solution like what Kamelia is offering, or you can have options to go ahead with multiple vendors, and then you manage the whole project.
What is the relation between Kamelia and Unique? Going to do installations?
Kamelia is a Unique Group company now, so we are the major shareholders in the company. Yes, sir.
Can we ask now? Okay.
Yes, you can.
Now.
Now. Okay.
Thank you. Sorry. The
Are you
projections
still
that
sticking to the batteries or?
no, life moves on. You know, my friends. Batteries are drained. The first point was you did a good presentation because we are involved in the stage 2 and 3 and 4.
Okay.
Zarmatic gives that kind of service. We leave the scrubbers to the ship owner. Now, your presentation was more based on people who are paying for the fuel. The decision making for scrubbers works if the fuel is being paid by the ship owner, as in the case of most likely container ships. In case of tankers which are not carrying in-house cargoes and they're being chartered out, the whole scenario falls through because who's going to pay for the fuel is the charterer. The ship owner will install the scrubber and unfortunately he gets no payback. He never recovers that money. So, you know, the target audience is a little differentiated there. My main question to you as a scientist was, what is the difference? Because we heard the commercial aspects of it, the actual engineering aspect. I did not hear the design aspect. What is the difference between what you are talking about and the scrubber which we are using on tankers? For
So,
the
inert gas
IGG,
tankers.
yes. What is the real difference? It has the dwell time, it has the spray, it has the volume of water.
Well, you need to cover the whole exhaust gas flow and cover the whole exhaust gas flow of the engine, and you need to clean it to a certain requirement. So that is the difference, and you need to make it economical. So you're not overspraying water, you're not getting back pressure to the engine. So that's the difference. Basically, you need to make it such a way that it has no detriment to the engine or the propulsion of the ship, and you're doing it as economically as possible, and you're cleaning it to the requirements.
Can I ask you a simple question?
Yes.
Have you tested the water coming out of a scrubber on an IGG or an IG plant of a normal flue glass and tested what that acidity or the pH value of that water is? Because and also the IG which we are putting into our tanks,
Yes.
how much sulfur did they contain? We know about how much O2 they contain, oxygen
Yes.
we have to measure. None of us have actually shoved in a sulfur meter and seen how much sulfur is there.
I would think
Which is a
it's-
mistake from us, because
Yeah.
if we had done that when we were sailing, I think today we would have not been considering scrubber towers as such. We would have just
Sure.
bifurcated the main engine and put it
Sure.
into the existing scrubbers, for tankers at least.
Yes.
So I need you to just give me two answers.
Yeah.
The water content coming out of the water from the scrubbers on IG plants.
Yes.
And the sulfur content in the air of the inert gas plant. If you will give me those 2 points,
Okay.
we can move on from it.
So in inert gas plants, the requirements are different. So because the requirements are different, you're using less water. So we would assume that you will get more acidic water out of an inert gas
I'm
plant.
sorry, I'm not asking for assumptions. Do you have an answer? If you don't, we'll ignore this topic, we'll move on.
I don't know whether you have the exact values.
Well, we have studied inert gas scrubbers. The acidity
can
is
share
around the
later,
same
yeah.
or a
We
bit
would like
lower.
to have actual figures. If you don't have them, no, it's not
No,
it's
no,
not a major
not at
thing.
this moment, because we are
I
not
think
looking
that's
at inert gas at this, or we are not looking at inert gas.
What you said is right, because we were all worried about the oxygen content there. We were all worried
Exactly.
about
Had
it.
we been intelligent
Yes.
and known this is what's going to come up, we would have shoved in sulfur meters and figured out, oh yes, this is what we need. Just bifurcate a pipeline or give a branch line. Remember, if you sailed in the late 80s, if you were there sailing, and
No,
maybe
certainly
I'm,
not, sorry.
I'm from the 80s.
Okay.
You used to have an exhaust system which went straight to the air or through the exhaust gas boiler, and you had a flap valve which you switched as the ship picked up speed, and you kept on increasing the boiler. We can do the same flap valve thing and put it into the scrubber instead. Killing the scrubber industry for the tanker market at least,
Yes.
because the tanker market is never going to recover the money.
Yes.
So we might as well give them that option,
Yes.
make it easier for the ship owners.
Yes, if the capacity of that scrubber is sufficient. And again, it is not, it's smaller.
Even if it is not, it costs $10,000 to make one of those, rather than $3 to $5 million. They have a footprint, they have
What you're
space.
forgetting is in inert gas plant, the inert gas goes into the tanks, not clear out of the funnel.
Yeah, but if it doesn't have sulfur content and we are putting a main engine sulfur, this is the conversation going on. It can be clarified. It's hypothetical. That's why I needed the sulfur. That's why I needed the sulfur
Because we are
content.
talking about two different animals here.
Yeah.
It's a main engine exhaust and.
That is why we were asking about what is the exhaust content content, sulfur content in the IGG, and how much is the acid rate. If you don't have the answers, then of course this question is useless because obviously the answer is not there.
Boiler efficiency of burning a fuel is quite different to a diesel engine burning fuel.
Yes.
The boiler that you are talking about for iGas is used only in a cargo, in a port when you are discharging for a day. But the main engine runs almost 200 days in a year.
So
you have to consider the boiler efficiency of how the boiler burns the fuel versus the diesel engine efficiency of how engine burns.
Okay.
If you know the two difference, then you will see that the question that you are asking is not pertinent because in port, you're using the boiler only for one type of cargo discharge.
So no.
Nobody's bothered about that.
I beg to differ. Volumetrically, you have tankers running on weekend runs, they're going 2 days up and 2 days down and tank cleaning throughout. You get to see the boiler running practically all the time. The volumetric flow per minute is high.
Yeah,
so
I think we should have a
this
separate
discussion
section
which
for
we'll take it upstairs.
Yeah.
We can take it further. I mean, it'll be a good discussion over a few drinks, I'm sure. Because it's a good topic to discuss further on that. Or maybe we should have another session on IGG, I think.
Yeah.
No, fighting is good.
Yeah.
Yes, it's good. I mean, it's good. I mean, to discuss further on it, everybody. Yes.
What will the time period between the execution of the contract and the installation?
It depends on what type of, as you've gone through the process of selection and all that, it can vary from 5 months to, it can go up to 8 months, 8 months, right?
Yeah, 8 months, yeah.
5 to 8 months of period. It depends on the entire project I'm talking about, right? From LOI to installation commission.
Which are the major shipyards you are associated with installing?
On the shipyard side, we are in touch with a few shipyards over in this region. I don't want to just name it, but in this region. Plus, we have our own installation and riding team, which can take over the whole project on our own basis. If you are not planning to have a dry docking, if you are planning to do it in a repair berth, it's possible to do for us to take up the whole project.
We are doing it in collaboration with installers such as John Aitken over there, and they are doing work on Voyage and used to it. And if shipyard is a more feasible solution for the ship owner, yes, we will go to a shipyard, and we will select usually the shipyard the client prefers.
One very uncomfortable question. If there are no scrubbers, we are polluting the air. Correct? You install the scrubbers, you are polluting the sea.
Again, let's go.
I'm being ignorant, I'm just asking. Because, see, before we used to have ballast water exchange, correct? Then they realized that with thousands of ships doing ballast water exchange, you now need a ballast water treatment plant. Moving 15 years down the line, they will say the effluent coming out from the scrubbers is killed all the pomfret and the habu fish, and therefore now we need to install something which will neutralize the
Wash water, yeah.
I think this is one of the cycle.
Sorry to be gloomy, but I'm just
again, let's go back to the orange juice analogy. So the wash water out of the scrubber is the same acidity as orange juice. And when you're in ports, you are not running the engine full speed, so the pH out of the scrubber will be higher than at open sea. And at open sea, there is a lot of sulfur in the water already. That's a part of the natural sulfur cycle in the world, and you are actually you need sulfur for the marine life to survive. And there, because of the alkalinity, which is the buffering buffering capacity of the seawater, you're actually neutralizing it 2 to 4 meters after the scrubber discharge. So it is completely neutralized. It's like putting a drop in a massive sea. It doesn't do much. The water, anyhow, for the past, I don't know how many years shipping has existed, you have had sulfur emissions to the air in open sea and nothing has happened to the sea. So port areas, yes, we understand. So there you operate anyhow in lower load. If the alkalinity is high in a port, it doesn't do anything. But if it is low, like in many cases you have rivers flowing to the port with fresh water which doesn't have calcium deposits, you are going to actually reduce the pH and alkalinity of that area. So it is a twofold thing. So in those port areas, I understand banning open loop scrubbers. Fujairah is maybe not one of those ports.
But
Yes.
in that case, you can dilute the wash water discharge with the seawater overboard, is it not?
Yes, you can dilute it, but then again, I don't think it is right because anyhow, the overall acidity in the vicinity, yeah, it's still the same amount of sulfur in that water, and it might not be able to take it. So in freshwater areas, it would be correct to switch to MDO or to operate in hybrid mode in closed loop.
Yeah, you spoke about sulfur again. I'm sorry, I keep bringing this up because things are hitting my head. You're saying the sulfur will not cause any damage or any changes in the seawater, but what about the carbon content? Because your scrubbers are pumping in black soot as well.
The black soot, anyhow, it does rain back to the sea. It doesn't deposit like if you go back to this one. So this is sulfur travels. Carbon doesn't travel as far. So anyhow, it will be dropped quite close to the sea, to the source. So that is the same as before. With the carbon deposits, yes, you're putting out PAH, so polycyclic aromatic compounds. So you are actually monitoring that if you go to slide before.
You want to put all the
so just before. So just one slide before. Yeah, so here you have limits to what you can actually discharge. And these have been scientifically actually examined. So open loop scrubber, you monitor what you're putting out.
Carbon?
Carbon, PAH.
And how do you justify that? By the amount of wash water that you put through? How do you calculate that?
It is calculated. Well, you monitor it, and it depends on the engine. So how much stuff or how inefficient the engine is. The more inefficient the engine is, more carbon deposits you have from lube oil, from fuel. So you need to take good care of your engine.
Yes.
Yeah, we calculate as well.
Where is your production facility and what is the typical delivery time after the order is placed?
Yes, Sharad, you can.
So when you talk about the production, we have a centralized design and engineering team. But one of the major costs into the entire project is you make somewhere and then you freight it out, you take it to somewhere else to install it. So that's the reason we are going to the concept of distributor on the various fabrication facilities. So we have availability apart from UAE. We do have options available in either in Mexico or in Scotland, or it can be in Batam or in India. So options are available as per your docking schedule or your sailing schedule.
These are audited facilities we have used before for oil and gas purposes. So they know how to use or how to work with high alloy materials that are required for scrubbers with thin walls as well.
And what is the typical delivery time?
Lead time depends on what configuration. It can range from either 5 months for the whole project, or it can go up to the 8 months.
And if you do all of the work on voyage with limited bed capacity, it can be a bit more. But it depends on how you are doing the installation and what is the preference of the ship owner.
Who is doing your fabrication in UAE?
We have an option with ourselves. We are based in the Hamria free zone.
And we have one facility in Jabal Ali, which we are more than happy to talk to. And Jabal Ali is one facility that we have audited in the past and used for other materials, stainless.
Is there any warranty or guarantee given on this product? If yes, what kind?
Definitely need to warranty it. So we're talking about a big amount coming in. So I want to talk more about how we warrant the operations.
So there is two kinds of warranty. One is process warranty, which is after commissioning, 1 year after commissioning, and then there is material guarantee. So we do guarantee that the material is fit for purpose for a longer period. So that's why we use higher alloy steel and we use proper coating at the ship hull side.
There is one question. So how you will be able to install during the voyage or at sea this big installation on big ships? How will you be able to do that?
Again, yeah, Richard.
I think Richard.
Yeah, just to answer your question, I'm used to oil and gas, and now the big lifts will have to be done at quayside during one of your port stops. There's no alternative there. You can't do it while the ship is in motion. You can't. You can't take it off a supply boat or something like that. You will have to do the big lifts in ports. So the big lift will be your scrubber and the seawater pumps. Now, apart from that, you're going to be cutting plate out and stuff like that. That's with, you can use various pad eyes, lifting beams, you've got turfers, you've got all the things that we're used to using in the oil and gas.
And during the voyage, you should keep in consideration the pitching, rolling.
Absolutely, yeah. There's only certain things you can do. So you can pull cable on voyage, yeah. You can connect instrumentation, instrument airlines, etc. The big lifts and the big stuff you can't do. Here you're talking about GRE pipe work as well, which it's heavy, but it's not like steel. So you can rig it and you can do it whilst you're in reasonable sea conditions. And particularly if you're installing low down, the pitch isn't so great lower in the vessel. So we're used to doing all of this in oil and gas. I've done it on lots and lots of FPSOs because we're usually late, and therefore you have to be doing a lot of stuff on voyage. Drilling rigs, we do it on drill rigs. These guys have done it on dive support vessels that are unique. So it is doable, but the planning is very, very key. You have to actually do certain things at certain ports where there's certain key access and there's certain lifting capabilities. So it's all in the planning. If you just turn up with all the kit, it's a disaster. So we specialise in planning very, very carefully. With infinite numbers of steps. I'm used to putting in big turret systems and stuff like that.
And also prefabrication as far as you can. Yeah.
This GRE piping is advantageous because you can do cold repair. I mean, GRE you don't. It's easy to repair as well, isn't it?
It is relatively.
This is a glass reinforced.
Yes, or GRP as well. That's one other one. So that is good. And what makes GRP and the superior material for this is the acid resistance. Yes. So, and
it is option available on that.
That's why it is used large in the sewage industry and
exactly.
Same principle, yeah.
Yes, sir. I have a question. Is there any limitation on the size of the scrubber with respect to the main engine power?
Yes, it is. Right.
Yes.
Which one you want to? We'll just look at the. Yeah.
So the size of the scrubber compared to the main engine.
Yeah.
So we always look at the exhaust gas flow, try to keep it to a limit, and we look at what type of engine you have, 2-stroke, 4-stroke, how much exhaust gas you're forming. The diameter of the scrubber depends on that. So we go from 2.5 meters diameter to 7.2.
I'm talking about the main engine power. For example, the main engine is 74,000
kilowatt.
So you have to have a bigger size of a scrubber.
Yes.
So do you have that size of a scrubber?
That goes over the 7.2. So in that case, what we would do is we would limit the MCR of the engine. So we would go to a 60 or 65 megawatt, or limit to 60 or 65 megawatt, and that is available. So going above that size, we need to look at the space available on vessel. And if you look at that big of a scrubber or that big of an engine, usually there is not so much room. You're looking at a container vessel. So you're digging into the container capacity. So you don't want to have a bigger scrubber that fits into the funnel. So we would limit the MCR, and we would have auxiliary scrubber separately to balance it out. So the auxiliary is connected to a separate scrubber to make sure that you have sufficient scrubbing capacity.
So we're talking about splitting it. When you look at the full exhaust gas, we do have apart from the engine, you need to look at the boilers and the auxiliary. Either you combine it or you split it, it all depends on that.
But it will take additional space, no?
Yeah.
If you are cascading something. So the whole of the ship will be with scrubber.
No. Usually, the bigger the scrubber, the bigger the ship. So.
Can we put in 2 scrubbers
yes.
in parallel?
Yes, you could split it into 2 as well. That's more expensive, of course. So this is something that might be attractive for a wider vessel, but you can definitely split the exhaust gas flow into two.
One last thing, this is scrubber is the last outlet here because exhaust gas, especially from the main engine, it is used for economizer. So after, just before it's going out of the funnel, that's the
exactly.
That's your. So you are limited in a certain way as to where to install the
yes,
scrubber.
exactly.
You cannot install it at the bottom.
No, it needs to be above the boiler.
Above the boiler.
Yeah.
And plus, you need to look at even on the back pressure. You have to consider the back pressure as well.
Yeah.
And one thing more, the wash water from the scrubber in the holding tank, you are dealing with it mechanically or chemically also? Because I can see in the picture what is there. What is this?
Well, this is not this is very vague on purpose, so I can show you an actual PNID later on. But this is what we are doing. We are treating it with alkali, and in closed loop, the pH out of the scrubber never actually goes below 5.8 or so. So you don't need to really treat it. So it is more, or the pH is higher because you're treating it with a very strong base, which is the alkali caustic soda.
Chemical.
Chemical, yes.
That's the dosing.
That's in the
mechanical.
Yeah, this is a chemical.
This is a chemical dosing.
So you're dosing it with caustic soda, which raises the pH very fast.
How many cubic feet of air or exhaust can be washed by the largest one that you just spoke about? Sorry, Kamelia, you just spoke about Kaisa?
Yes, Kaisa.
You spoke about a limitation on the capacity.
Yeah.
For 65 megawatts, you can treat the exhaust using one of your scrubbers. I did get the 7.2. Can you just relate for mathematical purposes? 10 megawatt engine, how much exhaust gas, how many cubic feet?
It depends on if you have a boiler or not.
Just the main engine, please.
So just the main engine. So, but I mean a boiler, exhaust gas boiler or not. So if you have an exhaust gas boiler, you're compressing the gas because it's less hot. We are looking at the temperature plus the kilograms. For a 10 megawatt engine, it's 18 kilograms. And then we of exhaust gas per second. 18 kilograms. And then we look at the temperature. So it depends completely. If you have a boiler, what is the temperature out of the turbochargers and this. So the volume is calculated based on that.
You don't have. Do you have a figure in cubic feet per minute or something?
Yes,
cubic
yes,
feet per
yeah,
hour?
yeah.
Or cubic meters per hour?
I can look at a table, but now.
No.
Yeah, I can look at a table, but now at this
You
moment.
can just give me a feedback. Cubic meters per hour.
Yeah.
And put it in Google and
Yeah. Well, it's 18 kilograms per second.
Go back to.
You find something interesting?
Yeah. Am I going forward or backward?
You're going backward.
That's the story of my life.
What's anything of interest? Apart from stuff.
What's the question started?
So sometimes prevention is better than cure, and at other times cure is better than prevention. Yeah. Although this is a technical seminar, it will be foolhardy not to consider the fact that return on an investment is a paramount factor to consider when making a decision like what we just discussed, between $1 and $1 to $5 million.
Yeah.
So I go back to the original statement, including what we read earlier. Ship owners are in a dilemma on what action to take. And just today I heard, obviously completely off the record, otherwise prove whether this is true or not, 85% of ship owners are still on the fence.
Yes,
more.
It could be more. Wow. More. Look at that. So
the fence is also bent.
Yeah.
That's easy because if the charter is paying for the fuel, the owners will not put the scrubber.
If it affects the charter rate, that might change the game a bit.
charter rates are affected by the demand and supply of the vessels carrying the cargoes. It doesn't get changed because you have a scrubber or don't have a scrubber. Yes, you may find favor. If you have a scrubber, I will charter your ship because I'm going to pay less for the fuel. Exactly. You don't get any money out of it. As a ship owner, you have installed 2 million. You don't make anything.
But then you're more competitive, isn't it?
Yeah, you get employable. Yes, you're more employable.
You're more employable. Yeah. But again, it goes back to the feasibility study that Sharad also mentioned. It is on a case-to-case basis, so it's not the one glove fits all.
No, it doesn't.
Sometimes, yeah, you just need to invest in yourself. Like even as a person, if I don't really need this extra course, but if I do that, then I'm more employable. Again, the same thing.
Because if you are looking at it from the scrubber manufacturer's point of view, we are doing the service as a service provider.
Yes.
We come in at stage 2, 3, and 4.
Yeah.
The decision for which scrubber to fit is based on us comparing your scrubbers. We normally would just give the right option to the owner so that he remain profitable. Because as long as he's profitable, we get employment.
Yeah.
You are talking only about scrubbers. We are looking at another range of services.
True. Many of the scrubber owners, they are still sitting on, not scrubber vessel owners, they're still sitting on the fence because they don't know how they will get paid back if they're not operating themselves.
No,
there is no.
There's a misunderstanding. 85% are not sitting on the fence. Near more than 50% have actually done the stage 2 and stage 3. They've done the 3D scanning,
Yes.
done their paperwork. They have in fact done the feasibility studies. They've not gone to the next stage of getting class to approve it and start the engineering drawings and the PRIDs.
Yes.
They've just stopped at the level where they've done the feasibility, they've got the 3D scans done, they're waiting. They're waiting to see which way the markets will turn.
Yes.
I'm happy to say the night is young, it's not over yet, and all questions will be answered over a little more interesting liquid than wash water.
Yeah.
Thank you very much,
Thank you.
Kaisa. Excellent conversation.